Hello, calculus students and seekers of general truths. In this video, we continue our study of improper integral with two examples here. And these are the examples of the first type where the limit of integration is infinite. So it's always helpful, at least early on, to visualize and see exactly what it is that we're working with by looking at a graph. So e to the negative x, okay, looks roughly like this. So it's the exponential function reflected over the y-axis, and we're not concerned with this part to the left of the y-axis since we're integrating from 0, and we're looking for essentially this area right here. Okay. And the way that we are going to approach this problem is almost like any other finite integration problem, except we're going to use a limit. So we're going to say that this area right here, or this integral that we're looking for, is equal to the limit from 0. And instead of using the integral symbol of the infinity symbol up here, we're going to use a particular variable in abstraction. Let's call it b. So the limit as b approaches infinity of the integral from 0 to b of e to the negative x dx. Okay. And then we evaluate it just like we do of any other integrals, except that limit comes along in each of our steps. So the antiderivative of e to the negative x is negative e to the negative x. Okay. And we're evaluating this between 0 and b, which we know then is equal to, and we're going to use this limit once again, b approaches infinity of negative e to the negative b minus a negative e to the 0. Okay. And let's look at this limit and see if we can make some sense of it. Well, let me be clear. This is minus negative e to the 0. Okay. So first, this last part here, minus negative e to the 0, that's just the same thing as adding 1. So that's not hard. Okay. Now, let's think about this. If we were to put a very, very large number into here, well, what would we get? Well, we would get we would get 1 divided by a very, very small number. Okay. 1 divided by a very, very large number. Okay. So that would effectively go down to 0. So I'll write it a slightly different way here. This would be the same thing as negative 1 over e to the b. Okay. And again, we're taking the limit as b approaches infinity. Okay. So you can see here, if I put a huge number into here, and I take negative 1 and divide it by that, then I would get a very, very small number. Okay. So small, in fact, that it basically approaches 0. So I have this limit here is going to be equal to 0 plus 1. So the area here under this curve, no matter how far you go out here on the x-axis, all the way to positive infinity, you will get more area. That's for sure. There's no doubt about that. You will get more area, but the amount of area that you get will never be greater than 1. And that's essentially what this limit is saying. So big picture here, whenever you see a limit of integration that is infinite, deal with it by using a limit to infinity. All right, I'm going to leave you to work on the second example here, and then you can check out the next video to see the worked out solution. Thank you for watching, and have a wonderful day.